Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good morning. Apa khabar semua? How are you?
Waalaikumsalam.
Waalaikumsalam, Prof.
Good morning, Prof.
Continue with the invited lecture. Okay, we have together with us this morning Professor Technologist Liew Chee Leong, my good friend. How are you, Ricky?
Morning, Prof. Can you hear me now?
Yes, loud and clear. Okay, so thank you very much, Professor Ricky. That just to give a brief introduction about Ricky. Mr. Ricky Liew Chee Leong is our adjunct professor. So, what is an adjunct professor? Adjunct professor is basically the University Putra Malaysia, we invite and appoint renowned practitioner from the industry, from the government sector, from other university that can assist in term of our delivery, giving advice to the program, and there are so many things that being when we appoint an adjunct professor. So previously we have other adjunct professors, but Professor Ricky, we appoint him in 2018 or 19? 19, yeah. Okay, so 2019. So and just a little bit of background about Ts Ricky. So he's a licensed aircraft engineers by profession, right? He's having category C, is large aircraft certificate by the Civil Aviation Authority of Malaysia. He has vast background, I think more than 20 years. Correct me if I'm wrong, Ricky.
32 years.
I'm trying my very best. How I know you. He has vast background in working with the aircraft maintenance industry. Started his earlier career with Malaysia Airlines, and he moved to I think KLM, if I'm not mistaken. Yes. Transmal, and so he has a long history of engineering background. Okay, and recently he already got his graduate engineer registration, and all of you probably has already know. Maybe this is the time that you know that the licensed aircraft maintenance, the certificate has already been accepted by the Board of Engineers to be substantially equivalent, meaning that whoever has the certificate of category C, licensed aircraft engineer, they can register as a graduate engineer. It's equivalent to the Bachelor of Aerospace Engineering, right? And then of course Ts Ricky is not graduate engineer by knowledge. He's far from that. That's why we appoint him as the adjunct professor. And then we have the second category, licensed aircraft engineer category B with type rating, right? With type rating meaning that the license is specifically to a type of aircraft. For example, like A320 or A380 or Boeing 737 and so on. So those category B with type rating can register as the engineering technologies, right? It's equivalent to Bachelor of Engineering Technology graduate, right? And then the last last category is licensed aircraft engineer without type rating, type B without type rating, where they can register as engineering technician, equivalent to a diploma holder, diploma of engineering, diploma engineering holder. So we can see that it is quite a huge impact to the aviation industry, where the Board of Engineers Malaysia already recognize the qualification and experience in the aviation sector, especially for the licensed aircraft maintenance community. So I believe T.S. Ricky can explain further about his experience in his company. Now he's the head of engineering of SR Aviation and handling many type rating. That's why we call him today, just to share the first lecture for our engineers and society. So without further ado, I give the floor to T.S. Ricky to give his lecture. Thank you very much.
Thank you so much, Professor Dr. Rahim. Let me just share my slides. Okay, a very good morning to Professor Dr. Rahim. A very good morning to all the fellow future engineers, of University Putra Malaysia. It is a great honor for me to speak to you from Subang Airport, in my hangar and also in my library, coming in from a real engineering working environment, speaking to the students, the third year students, that very soon you're going to graduate and you're going to go out into the society and make an impact, make an impact to the world that we live in. Now, engineers and society are very, very closely related, and we are part of the society, and whatever that we do, we actually will make contribution to the society, so it is a very special form of very intimate kind of relationship between the engineers and society. Can you imagine today we are able to speak? I'm able to be in my library in the Subang Airport, and many of you are everywhere across the Malaysia, and you are able to despite having the risk of pandemic, COVID-19 pandemic, but we are able to continue with our education, with our learning, with our classes and on, all because of one thing. It is actually because of the engineers that have designed and developed the technology that allow us to continue to work safely in the society. So that is one of the impact that an engineers have to the society. We make solutions, we give a lot of solutions to the society, to the public, to the people. Now, my session today will be about 1 hour. And during this 1 hour, what I'm going to do is that I'm going to cover a little bit about introduction of the profession, introduction about myself. And then I'm going to describe a little bit about take you through into the engineering profession, and show you some of the general image of the engineers, in the past and also current, and also we're going to touch about the professionalism of an engineer, and how international level indicator, how internationally the body like United Nations, like what Prof. Dr. Rahim has mentioned just now, there are so many elements inside the engineering sustainability of the world that actually engineers are actually part of it. Engineers are part of it. So that is how important the engineers are. And I'm going to conclude, give a short conclusion also, also from the United Nations, actually from UNESCO, that's advised to us, and also subsequently I will discuss about assignment. Okay, this has been briefed by Professor Dr. Rahim just now, so I'm not going to go into this slide again, but I want you all to know that when we as a student, when we attend classes, you have to be very focused in terms that you hope that after completion of this particular course, you will be able to achieve certain things. We don't want to attend courses because we are asked to attend courses. We do not want to attend courses because it has been scheduled by the university. We attend courses because we want to achieve certain things. And this is the very good learning outcome that Professor Dr. Rahim has actually given to us. So as you continue in your class, always review back to this learning outcome. Are you achieving this or not? If you are not, yeah, find out the reason where you are missing and discuss with your fellow coursemate, and also probably can also discuss with the Professor Dr. Rahim, which part, that I think I am not covered enough, you always reflect back and go back into the learning outcome. Because why? At the end of this class, you should be able to do certain things, yeah, as an engineer from this module. Okay, before I take it further, I want you all to quiet down, yeah, and do a self-reflection. Reflect back into yourself. Ask yourself, why do you take up engineering course? Can you reflect back yourself and think back? Now you're in the third year. Remember 3 years ago or 4 years ago, you applied to UPM to take up engineering course. Can you reflect back? What is the reason that you take up engineering course? Think about it for a short while. Why do you take up engineering course? Okay, many people take up engineering course with different reasons. Now, if your reason, it is not about the passion about engineering, you need to be passionate, learn to be passionate about engineering, because engineering benefit the living beings and the people in the world. Which means that engineers are problem solvers. You must like this. You must like using, you must like and enjoy using mathematical engineering principles. You must like that with the skills that you have acquired, with the knowledge that you have learned during your 4 years in UPM, after 4 years, you have that ability to solve problems of the people in the world, whether it is a transportation problem, whether it is a construction problem, whether it is actually a network problem, whether it is an aircraft problems. All these things, you have been given the tools, the knowledge, and the skills. So you must use it. You must learn to apply it to the society, and you need to enjoy it. Because a lot of people take up engineering because somebody asked them to do. People take up engineering because they have no other choice but to take up engineering. So this kind of mentality or mindset, you have to change it. You have to change it. Because why? If you don't have a passion in engineering, you will not excel. You will not excel in the engineering field that you have chosen, whether it's civil, mechanical, whether it is a materials engineering, whether it is aerospace engineering. You won't have that thing. Because for an engineer to excel and go very, very far, just like the person in the picture here, Elon Musk, if you want to go as far as like him, you can see the strength of his passion in engineering, in giving solution to the people problems, has taken him so far. So solving problems will be something that you enjoy, and you use your critical thinking to help solve the small to global issues that we're going to discuss afterwards. You enjoy it. So a lot of people made the wrong focus. They wanted to come into engineering to make money. Their primary focus is to make money first. Come to engineering, so that they learn up engineering and go and then earn a lot of money. There's nothing wrong with it, but that is the wrong approach. Your approach should come from the passion in engineering, just like Elon Musk. You know, has a very strong technical inclination, where he actually was so good at his skill and he made his money. So money first, or is it skill first, or passion first? It is always passion first. If you have the passion, money will come naturally later. But if you focus on the money first, then you realize that you will be very grumpy, you'll be very frustrated because you don't hit the money first. But in the first place, you don't even have enough skill and passion yet to build that money. Yeah. So make sure that whatever mindset that we have today, the reason we take up the engineering course is because we have a very strong passion in engineering, and we wanted to solve problems of the people, of the society, and to benefit the living beings and the world, especially from the perspective of safety. It is very, very important that engineers place safety as the #1 priority. Okay. Now, let's go to look at this picture. Okay. How many of you can recognize the people in this picture? Of course, I know everybody recognize Elon Musk here on the right hand corner here. But the rest of the guys, any one of you can recognize? Can you just share with me your opinion? Anyone can recognize? Just tell me.
Nikola Tesla.
Yes.
Okay, Nikola Tesla. Who else?
Steve Wozniak.
Okay. Who else?
Steve Wozniak.
Okay. Good. Anybody else?
Also Roman Khan, Jeff Bezos.
It's good that you all recognize some of these engineers. Sometimes when I do presentation and I show this picture to the students, and you realize that a lot of students can only recognize Elon Musk #1, and then the other person is Nikola Tesla. The rest actually they don't. The other one is the Apple co-founder. These are the 3 people that they actually recognize. Now, of course, yeah, these are the 12 engineers that we picked up from. I mean, I picked up randomly from the internet. But actually, when we talk about engineers, there are a lot of very, very, very good engineers who have actually made a very substantial contribution to the way we live today. The houses that we live, the car that we drive, the irrigation system that we have, the water treatment plant system that we have, they have made a lot of contribution, you know. So the common characteristic of this group of people here is that they are all engineers and they are all inventors. Okay, they were just like any one of us, living in the common society. And actually, when they see the inconvenience of people, for example, on the left, this person here, Nicholas Otto, we initially they were riding horses, right? In the 19th century, in the early centuries, we were riding horses and all those. But how many horses are there to actually for people to ride? And only the rich can afford the horses. So he came up with the internal combustion engine. When we have a internal combustion engine, then we talk about we have motorcycles and we also have cars and automotive. So even up to today, his design of internal combustion engine is also being used by the people even till today. We talk about Mercedes, we talk about Proton, we talk about Perodua. All these vehicles have internal combustion engine. Can you imagine today, if we don't have internal combustion engine, we do not have Nicholas Otto, who actually came up with the internal combustion engine. Can you imagine what we'll have today? Are we still riding horse, or are we still walking on the road? Yeah. So this is the common characteristic of people that actually brings benefit to people like us. You today, for about 48 or 50 of you all here, congratulations, you are part of this group of people. Do you see your importance? Do you feel that importance, the pride that you have being able to be a university student doing engineering course, which in another 1 year or 2 years, 1 or 2 years time, you'll be graduating, going into the society, do things like what they have been doing. So it is a very special breed of people, yeah, that engineers can design, can invent something that actually bring benefit to people. And guess what? Don't ever think that maybe all the design no more finished already. Don't ever think that, what else? There's so many things has been created and designed by engineers. What else is there? No. There's a lot of things that is still not developed yet, that require people like you and me to continue to give inputs into the society, to all the companies, to all the engineering manufacturing companies. Yeah. So it is very important to think about what the world, our life will be if there is no internal combustion engine. What happens if there's no electricity? For example, Nikola Tesla came up with the AC power system. Imagine today in this world, we do not have an AC power system. And if we are still on the DC only, what is the impact to the way we live? We will cause a lot of inconvenience, a wastage of a lot of resources. But Nikola Tesla came up with the alternating current and actually distribute to the whole grid and the network system. Today we can enjoy, we have online classes, we have good lightings, we have good street lamps and all those. So can you imagine life without an engineers? For example, aircraft. We used to travel by road, we used to travel by ship. All right. Imagine in the 1903, 1903. Some of you are aerospace engineers here. In 1903, one of the greatest design and invention and engineer, the Wright brothers, make such a huge impact, a very revolutionary flight control design. Before that, people has been trying to fly, people die, people break the leg, break the bones and all those. It was only the Wright brothers that came out with the flying machine, heavier than air, putting on a engine onto his small little plane, and he fly and he managed to control, given the directional control, pitch control, roll control on the airplane. It is because from that point onwards, a small little design that actually bring us to what we have today. We have the best airplane in the world. We can fly from Europe, from Malaysia to London in less than 12 hours, 11 hours. Because of what engineer like Orville and Wilbur Wright discovered and designed. So you can see that engineers basically will actually cost a lot of convenience and growth into the society. Your inputs, your knowledge, your skill, the way you think, the way you behave, the way you comply to the rules and regulations benefit the society. That is how important engineers are. That is how important engineers are. So engineers and society cannot be separated one. So we actually have a duty of responsibility. We actually have a duty of care, because we have not everybody can study engineering one man. Not everybody can study engineering. People must be good in mathematics. people must meet certain level of requirements and criteria. Then only you qualify to come into UPM and start your year 1 program. Not everybody. So it is a group of privileged people that you have the knowledge, the skills, especially your mathematical skill, plus your ability to solve complex problems. Engineers solve complex problems. What is complex problems? For example, the climate, the climate that is getting hotter and hotter. What kind of houses or what kind of air conditioning system, what kind of cooling system that we can design but will not harm the environment? This becomes a complex problem. It sounds simple. What kind of airplanes, what kind of airplanes that we can design that doesn't produce carbon dioxide emission that will actually pollute the environment? This is a complex problem. So engineers have the knowledge, skills, and ability to actually solve this complex problem with sound engineering solutions. For example, I recently saw that we have this electrical vehicle. Of course, electrical vehicle is definitely good. Yeah, electrical vehicle cars are definitely good because they don't have this gas emission. But another group of engineers, came up with another new design and technology, which is actually using hydrogen to produce electrical power to power electric cars, and the byproduct is water. The byproduct is water. So this is also another innovation, new kind of technology that another engineer came up. Then my question to you: can you come up with a third alternative, or fourth alternative, or fifth alternative? Engineers can, yeah. If you put your focus, your knowledge, you will be helping the people in the world, especially in terms of sustainability, especially in terms of preserving our resources. Don't waste our resources. Save the resources for our future generation, because the resources of this entire earth, it is only about that much. So we are talking about engineers and sustainability, and the society becomes very, very important. We can build a lot of things. We can design and build a lot of things. But in the course of your design and developing, let's say a metallic structure construction, a strong one, but if you keep on consuming, the earth resources, then eventually we don't have the resources anymore for other things. Yeah. So if you look at this slide here, you can see Mr. Bean, yeah? Mr. Bean. But do you know that Mr. Bean is also an engineer by training? I think you all know, right? So engineers have so much of capability. Apart from actually designing things, solving complex problems, they can also be get involved in other profession. Yeah. Okay. Now, one of the recent incident that I will share with you now is that I think many of you have actually watched the United Airlines engine fire. Do you all know that about 2 months ago, there was a 737 flew in the air, and it actually exploded. The right engine actually, the fan blade actually fractured, and then it causes a fire on the engine. Okay, can you imagine a Pratt & Whitney, a 777, a Pratt & Whitney engines, yeah, that is so powerful, yeah, giving about 70,000 pounds of thrust, so powerful at takeoff power, and with such a high power, the engine fan blade fractured and cut off the whole nose cone, yeah, the inlet cone of the engine, and actually it just dropped off. And despite the heavy vibration and the heavy fire burning, despite the whole aircraft was shaking, the pilot has to shut down the engine, and the fire was burning, and it is very close to the fuel tank. Guess what? The airplane came in and landed safely. All people on board safely landed, no injury. Everyone was actually in good condition. Now, what can you say about this? What can you say about this incident? I can only say the engineers that designed this airplane did an excellent job, because he has prepared in case of the engine failure and explosion. Even though there is a fire, the aircraft will still be very safe to fly and land with no injury to the passenger. This is an excellent design about the skills and the knowledge that design engineers have. You can be one of them as well. Yeah. Now, in the past centuries, in the past, even thousands of years ago, 2,000 years ago, people has been starting to design things. Now, if you look at this slide here, can you tell me on the pointer that I'm pointing now, can you tell me who designed this? It's a very, very smart and simple design that actually solve our problem. To carry the water for irrigation, instead of using pail going through and off to the river just to carry water with your hand, this one very simple. They just use the screw and they just turn, and the water keep coming out, rather than getting the pail, walk down to the river, come back to the river, walk down to the river, and come back to the river. As long as you turn it, the water will come out. Can you tell me who is the engineer who designed this thing? Anybody? And in fact, this design here, in some of the rural areas in Malaysia, very, very rural areas, we can still see people using this design, taking up the water from the river right up to the place where they can collect the water easily. Any idea who designed this? Nobody want to try? This is actually done by Archimedes. It is actually called Archimedes screw. Okay, it was designed by Archimedes about 300 years BC. About 300 years BC. You see, a simple design like this actually can solve our water problem, our human limitation in terms of carrying pails and water. We can solve that problem. All you have to do is actually just turn that thing, the Archimedes screw, the water come up, put a pail underneath, and then just move on. Put a pail underneath, just move on. And Archimedes, the engineer Archimedes, also developed the pulley system. The pulley, when we pull up lift up the heavy stuff. Who came up with the pulley system? It is actually Archimedes. So solving, people cannot even carry more than 50 kilograms are already having very hard already. Archimedes came up with a pulley system, can carry, one person can actually pull and lift hundreds of kilos. Isn't it an engineering contribution? Of course, nowadays, we don't use so much of this Archimedes screw. Because why? Because engineers came up with a water pump. Water pump. Rather than using an Archimedes screw, engineers have designed and developed a pump using electrical power. All you have to do is to switch on the electrical pump, and then you actually bring the water from a very, very far distance to wherever you want. Just install the piping and the routing of the pipe. You will get water up on the 30th floor, 50th floor, very far, 20 kilometers away, 50 kilometers away. So that actually solved the limitation of Archimedes screw. So this is engineering contribution. This is engineering contribution. For example, the construction, the housing construction that we have today, if it is not because there is a civil engineers, who are good in designing houses, who are good in designing a good structural houses for the buildings and all those, we wouldn't have the metropolitan city that we have today. We wouldn't have a house that we are staying today. We wouldn't have a nice big block of buildings in the city, where people can go in and have their offices and all those. Imagine that contribution to the society. And of course, the world famous one is actually the Henry Ford, the T-Moto series. You can see from the car here, that actually revolutionized the way we travel. We used to be, riding bicycle, riding horses, and because of Henry Ford, they came up with a T model of the car. You realize that subsequently there's so many BMW came out, Mercedes came out in the German, in the Europe, and the American famous for the T model, and we were able to travel conveniently, fast, for hundreds or even thousands of kilometers today because of the automotive vehicles that we actually designed. But mind you, human being always have the tendency to explore further and further and further, and that is where we came, moving fast forward, we actually gone into the rocket technology. We design rockets. We design rockets, flying machines that not only fly to moon, but even fly to Mars. How many of you have watched the recent landing, of the Mars rover in February? Any one of you watch? Yeah. Okay, that is actually a magnificent achievement of the human beings. Why? That expedition actually allows human beings to actually explore further, to find new avenues for people to stay, to find avenue of resources. Maybe we have on the planet that we have on Mars, there were other minerals, that can actually be brought back to the earth and also to be used, on earth. So all these are possible because of engineering. Because of engineering. Without engineering, this is not possible. Yep. Now, engineering, it is not just about designing and get things done only. You have to understand our position in this society. We have ethical responsibility towards them. You see, engineers can design things that benefit people, but engineers who are irresponsible can also cause a lot of damages to the society. And this is what we do not want. We want engineers who are responsible in shaping how the society looks, in shaping how the world, the infrastructure, the systems, how it benefit the people positively. Do you know that when before the arrival of DC power, before Nikola Tesla implement his AC power system in New York, what was the primary power at that time? What is the primary electricity power in New York at that time before Nikola Tesla? What I'm saying is that during Thomas Edison time, what is the primary source of electrical power? Any idea? It is actually the DC power. Thomas Edison time was using primarily on the DC power. But because a lot of losses of the DC power, so they have to build a lot of DC powered stations around the New York City. And this DC power has one disadvantage, because there's so much of connection and wirings. The horses in New York at that time, when they step on those DC wires, sometimes and quite occasionally, they actually get a jolt of electricity. So what happened is that the horse are always, being in a very wild condition. When they get the jolt, they will actually become very wild, So this is actually a social economy problem. This is a problem there. Until Nikola Tesla came up with the AC system, a new laying of the grid and the wire system into the New York. That actually solved the problem. So now my question here is, when we design our systems, when we produce our technology as an engineer, we are always thinking about what is the effect and the impact to the society. How safe are they to the people? How safe are they to the environment? How safe is our system to the user? How safe is it to the user? All these are key important points, that we actually need to know. If you look at the diagram that we have here, yes, engineers are the key people in building a modernized society. Yes, engineers are the people who actually built the strong infrastructure for our convenience of living. But if you look at the picture on the right hand side, this happened quite nearby to Subang Airport a few years ago. The bridge collapsed. Why did the bridge collapse and kill the workers underneath? Did we even thought about that when we first designed this bridge? When we implement our design, did we even look at the system whether it is safe or not? Because we were not careful, that bridge collapsed and one person died underneath the bridge. Now, same on this picture. Yes, we want to produce power. We want to produce industrialized nation. But remember, the industry that you design, the process that you develop, is it producing a lot of gases, greenhouse gases? If your greenhouse gases is producing too much, what is it going to do to our Earth? Our Earth is going to get warmer and warmer and warmer. And that is a big problem. Even a 1 degree centigrade looks like not much, but actually a 1 degree centigrade temperature rise on Earth has a very, very strong impact to the way we live. So can engineers come up with more sustainable kind of design? Yes, we can, but we have to be responsible. We must be ethical. Okay. Now, what are the engineers' social responsibilities? How do you carry yourself as an engineer with a strong social responsibility? And we are like that, and we must be like that. We don't let commercial pressure, business pressure, because of other, personal business kind of achievement or target they want to achieve. They pressure you so that you comply to what they need because they employ you. No. As an engineer, the number one thing you need to do is, you are an engineer, you uphold the dignity as an engineer. Many years ago, it was during the election time, an airplane actually came back. And I went and had a look at the airplane. It was during the election period where the airplane was carrying VIPs. I went and looked to the airplane and I checked the system, interrogated the system, and I said, this aircraft is grounded and cannot fly. And I told the management, the top management, I said, this airplane is not safe, therefore I am not releasing this airplane to fly. They came down to me, hey, Ricky, you cannot do this. It is an election time. You know, this is Dato Seri, something. He must be at the certain place. Otherwise, the election going to gone. Election is going to lose. He cannot push his campaign. Dignity uphold. As an engineer, I said, this aircraft is not safe to fly. I'm very sorry for the inconvenience. You have to find alternative. Either you go and rent a helicopter or go on transport or ground transport or postpone your campaign or whatever. But as far as I'm concerned, this aircraft is not safe to fly, and actually I'm protecting the aircraft and also the people. Uphold the dignity. I'm very sure one of these days when you go into big companies, they want targets, they want objectives, they will pressure you. Hey, you as an engineer, come. You all you have to do is just sign this off. Then we can actually produce these products. We have a time pressure. Uphold the dignity. Look at the requirements, whether it is safe or not. Okay. So do not violate the requirements of engineering design. Don't violate it. Yeah. Safety is always the priority. Then only we talk about other things, financial lah, privacy lah, diversity lah, aesthetics lah, want to look nice lah. Always start with the safety first. Without passing through the safety level, don't go to the next stage. That is the engineer's uphold of dignity. Okay. Number 2, engineer's social responsibility. Fulfill the design products, design a product, process or product that may have side effects. Yeah. You have to fulfill the design carefully. That means you do not want that you design something, but then it is actually not safe one, or they have other byproducts. For example, you can design a very nice sewerage system. Yeah, let's say you are a civil engineer or you're a water environmental engineer. You design a very nice sewerage system. But then in your design, the cost of maintaining this sewerage system is very, very high. And municipal, the Majelis Perbandaran, the government have a restricted budget. Then you have to consider, is there any other possible ways that we can actually design the sewerage system in a much more cost-effective and practical ways? This is also our responsibility. Same also for the effect and all those. Yeah, negative effect to the environment, you must consider it. Okay. Now, you must also make provisions for the consequences of the design failure. Yes, you are good. You understand the system. You understand how to design, how the load path should move, how the systems stay. What is the load safety load factor in your design? It is good, but you must also remember, give provision in the consequences of failure. You must. For example, Apollo 1 fire. Okay, anyone knows what happened on Apollo 1 fire? Do you know what happened on Apollo 1 in 1967? The engineers in NASA engineers are very good, but they missed this element number 3 here that I'm mentioning here. Do you know what happened on Apollo 1?
Fire in the cabin.
Yeah, the cabin exploded.
Yes. Okay, what happened is that they designed a very good system, and during the testing of the Apollo 1, pre-launching testing, there was actually a high voltage in one of the circuit, and because yeah, the capsule always have pure oxygen, correct not? So they have a lot of pure oxygen in the capsule, and they were 3 of them were inside, and that high power that actually created a fire, and all 3 of them burned life a day because it was fed by the rich oxygen environment in the command module. So these are the things that you have as an engineer. What if this failed? Are they safe or not? What if a system number 2 or system number 1 fail? What is the backup? All this we need to know. Yeah, it is our responsibility. And then if there is a failure in the design, you know, you have put in so much hard work, you design, let's say, a aerodynamic system, a stall warning system that is so good, but you realize that eventually it actually is not working. You do not hesitate to stop, and then let's go back to the design board. Let's go back to the design board and re-look at the thing again. You know, even though you have already spent 2 years, that is our responsibility. Do you know that the Boeing 737 MAX incident have this problem? Do you know? Eventually they realize after the 2 crashes, how come there is only a single angle of attack sensor on the 737 MAX? Why is there no redundancy? Why is there no duplication of the system? And that actually killed 300 over people. And during the investigation, the Boeing CEO and was being asked, didn't you ask yourself, why is there single sensor and not 2 sensor? And that single sensor plus the MCAS system, yeah, is the one that actually caused the whole aircraft to actually crash and 300 over people died. So do not hesitate. If you need to redesign and go back into the system, go back to the drawing board. As a responsible engineer, we have to do it because safety of the people is always our #1 priority. Okay, and then also the 5th one is that have a clear sense of the meaning and understanding of the evolution of the role of engineering technology. Every time there is an evolution of technology, for example, we can see recently the disruptive technology. Understand the implication to the people. Understand how this thing can use to benefit people, and also see things, how it can actually be abused by people. So we engineers putting protective system, you know, come up with a protective system so that people are all well taken care of all the time. For example, I just give you an example. Today we want to prevent pollution because of the greenhouse effect. We want to protect the earth. People are trying to find ways to produce hydrogen, use hydrogen, you know, as a source of power, you know. So you can see from this diagram on the left, on the right hand corner top here, Toyota actually is using the cow manure. Cow manure means what do you call it? Cow dung, to actually use cow dung and process and get the hydrogen out. So this is actually something that I think engineers can do, yeah, in order to actually protect the environment using cow manure. Can you imagine that? Actually, it was told that based on the read-up that I had, 1 year the cow manure or the calf manure, a certain portion of it can actually produce power to produce hydrogen for 1 year for a car. That is how people have tapped the resources. This is engineers' work, yeah. Now, the other issues that I think we have to address here is that we are facing every day is actually the environmental issue that we are having now. Okay, fossil cars, yeah, is good. It has been helping us to move easy here and there. We are able to go to shop. We are able to travel. Airplanes also the same thing. We are having a 777, A380, you know, 747, and all 787. All this has created convenience to us. has been designed and developed convenient to us. But we are also facing another issue now. And this issue is actually very wide-spoken environmental issues. When we talk about environmental issues, what are we talking about now? When we talk about environmental issues, what are we talking about? We are talking about the greenhouse gas emissions from the factories. Yeah, from the industrialized nation, we have a lot of factories. These factories are necessary because we are going into the industrial, we are in the industrialized nation. We need to produce and develop items, products. But factories are producing greenhouse gases. Plants are when we talk about plants, we are talking about production plants producing greenhouse gases. We are talking about vehicles producing greenhouse gases. And engineers today, especially those, we are talking about using recyclable energy. We are talking about clean energy using electricity. We are talking about solar power energy, that a lot of engineers are developing. All these are alternative that engineers can do to actually help to save the environment. Eventually, what do we want to achieve? We want to achieve a clearer and cleaner skies. We want to find, we have cleaner seas, clean waters, and rivers. Do you know that just by 1 degrees of centigrade, we will lose about 1 degrees rise centigrade in the earth. About 70% of the world population will lose the water. Or 1 degree rise, your crops, your food crops, for example, your jagung, your jagung will grow but cannot have jagung one just because of 1 degrees of temperature rise. So you see, anything that we produce industry from the engineering perspective, we make sure that we protect the environmental. Okay, now this is a session that happened after the JT610, the first 737 MAX crash because of the wrong design or the bad design. I was actually called for the interview on one of the online radio station, and we discussed about the responsibility of the engineer. The responsibility of engineer. Of course, on that day, it was actually a day where I discussed about, if I'm an aircraft engineer in the line, and what will I do if I encounter a problem like what happened on JT610? Do you know that JT610, the stall warning system of the aircraft did not happen once or twice. It happened already a few sectors ahead. It already happened a few sectors ahead. When it came to the engineer in Denpasar, in Bali, the engineer just as a normal do a regular checks, and then he released the airplane. Now, my question here is like this. If you're an engineer and this aircraft has been flying for the last 7-8 sectors, giving the stall sticker warning, every sector, the engineer on the ground say, ground test, pass, no fault found. If they repeatedly do the same thing and it reach to you as the 7th sector or the 8th sector, and you are the engineer who is receiving the airplane, are you going to say ground test pass, no fault found, and then release the airplane back? No, you cannot. The problem is you do not know what is the problem with the airplane. So as an engineer, this is our responsibility. Like I said, do not hesitate. Do not hesitate if the safety of the airplane and the people is involved. Ground the airplane. Never mind. Even if I lose the job, it's okay. Because why? uphold the dignity of an engineer. That is our duty. Yeah. Okay. So this is actually the carbon dioxide emission. Yeah, coming out from the from the world. Yeah, and you can see from the 1900 onwards. Yeah, all the CO2 has keep on rising and rising and rising and rising, and all this 1 degree is all it matters. 1 degree heat wave duration, you get strong heat wave, rainstorm intensity, sea level rise, you know, the sea become very, very rough, unstabilized, you know, all this, the coral reef will be wiped out, crops cannot grow, you know, fresh water would actually be reduced. So remember, any work that we involve as an engineer, think about what we do, what we design, the process that we develop, how we actually lay out the infrastructure. What is the impact to the society, to the people? Okay. So under the environmental and issues, engineers have a lot of responsible. The most important thing is sustainable. So you will have social responsible, environmental responsible, economic responsible. You have the eventually is that engineers need to think beyond regular tasks. You need to actually think and incorporate the elements of sustainability. Sustainability means you have preserve the resources, you know, prevent any wastage, so that the future generation, yeah, can actually do with what we have in the limited resources. Yeah. So concept of sustainable engineering is that it is a process of using resources in a way that do not compromise the environment. Yeah, engineers have that responsibility, or deplete the materials for future generations. We don't do this. Okay, we are very careful with this. It requires an interdisciplinary approach in all aspects of engineering. It is not just about civil engineering. It is not just about the structural engineering. No, it is all the engineers, whether you are electrical, electronics, whether you are manufacturing, whether you are in the civil, whether you are in the environmental engineering, whether you're in the aerospace sectors. All this is our responsibility. Together, we have to uphold this responsibility in ensuring, yeah, sustainability is always there to improve the quality of the life for all. Okay. Okay. This is a few things that I add on a little bit. I just add on a few more slides, few more minutes. Now, people think, how do I do sustainability? How do I do it? Okay, I know the skills, I know the knowledge. So this graph, this table here will show you what are the sustainable measure. Okay, design that reduce energy use or emission. Design complying with the environmental standard and regulation. So you need to read the law, like what Prof. Rahim has actually said. Look at the Board of Engineers, the Act. Look at the law. Yeah. So we need to understand and comply to the law. Design using renewable, recyclable materials. Design that reduce material waste in manufacturing. Design with non-toxic materials. Design with low carbon footprints. Manufacturing with less energy and natural resources. All this that you can see here will give you an indication how do you fulfill your responsibility in terms of sustainability as an engineer. Yeah, it's all here in the slides. Okay. Now, most likely the factors influencing organizing to use green design process and procedures. Number one, regulatory requirements. Please comply to the rules and the regulations. The client demands. A lot of people nowadays are more and more aware about the environmental factors in our life. So if your client do not understand, we as engineers take up our responsibility and educate them, share with them, you know, because they might not have the knowledge, but we have. Yeah, share with them what is the constraints, what is the limitations. If we design like this, I would suggest we design like this, you know, these kind of things. Yeah. So rising energy costs, ability to gain market advantage, and most of all, please make sure regulatory requirements is very important to we as engineers. Yeah. Now this is the conclusion slides. This is actually from UNESCO. Yeah, you can actually find it in the United Nations website, exactly like what Prof. Dr. Rahim has mentioned just now. All of us, yeah, in the industry, as far as I know, people that I know, we are very particular. We are very focused on this what they call it, this concept of sustainability. Yeah. So United Nations told us through creating and maintaining the physical infrastructure. This is engineers' job, that help eradicate extreme poverty and hunger. You see, what we do can help eradicate poverty and hunger, achieve universal primary education. See what we can do? We can actually, because of what we do, can actually help to achieve primary education for a lot of poor and undeveloped countries. Reduce child mortality. You know, we don't want people to die at young age. Improve maternal health. Parents are getting healthier. Women are getting healthier. Engineers, you see the word here? Engineers are demonstrating their social and environmental responsibility to sustainably develop societies. So the keyword here, coming back to the engineers again, all right? You can see from now how we can impact the society, just like how Nikola Tesla, how Archimedes, how Nicholas Otto impacted the society. You and me are also, yeah, can do the same. We are part of the group. So I'm very happy. I'm very happy that we have a group of very what they call it, enthusiastic engineering students in UPM, because to me, Malaysia need you and the world need us. Okay, so that actually ends my presentation. Yeah. Any questions so far before I go to the assignment? I mean, sharing the assignment. The assignment will be by Dr. Rahim. I'm just sharing some assignment questions only. Any questions so far? Okay. Now, if there's no question, I'll just go through the next assignment. These are the assignment that I've put in, and Dr. Rahim have this assignment. As a responsible engineer, describe how should design and implementation of sustainable engineering work be carried out to maintain a socio-economic well-being of living beings. Yeah, this one is very much tally with what Prof. Dr. Rahim go out and do certain projects. Yeah, this is actually related to what Prof. Rahim has mentioned just now. Yeah. Describe what is your role in your engineering field in responding to society needs as well as shaping them up realistically. Yeah, you're talking about sustainability here from the perspective of sustainability. Engineering development impacted our life daily. Would the societal consequences, this is a discussion, yeah, would the societal consequence have a different if engineers has been involved in a more systematic study of engineering complex role in the society, had a work dialogue session with social scientists, and have better communication with public? That means if, let's say, the government want to implement certain projects, is it better for them to engage the engineers to come in, have a discussion, dialogue session before they really start their projects? Will it make a better environment, a better outcome, or better output? So this is actually what the question is all about. Yeah. And responsible engineers, yeah, be responsible engineers at the end of the day. Let's be the responsible engineers at the end of the day. And that actually concludes my presentation. And I would like to hand over the mic back to Professor Dr. Rahim. Thank you so much for your attention.
But I would like to open discussion for or any question to Professor Ricky, and I think he has a lot of thing to share with this very limited time. Okay, so any input or question from all of you? Anybody would like to start first? Okay. What are the requirements needed for license as a practicing engineer? So maybe Ricky would like to try to answer first.
Thank you so much for the question. Yeah. Okay. Licensed engineers if we are talking from the aircraft maintenance perspective, licensed aircraft engineers are actually a special kind of a program that graduates can actually take up the program. It is usually about the 5 years program, and the entry requirements, what I've seen in the past is that we have people who came from a good SPM result, people who started at a very young age or the age of 18. We also have people, graduates from aerospace engineers, who actually after graduating, they decided that they want to take up this aircraft maintenance engineering program. They also enroll and actually take a 5 years program to get the license. And actually there are a lot of quite a few aircraft engineers and mechanical engineers. After getting the degree, they decided to pursue onto the aircraft maintenance engineering program. So it is actually a choice of the people, where depends on where your interest is. Some people are very good in design, like some of you, like I think Dr. Rahim is also one of them. People are very good in coming up with design and all those. But there are also a group of people who like to actually not so much on design, but they really like to get involved in actually in the operations and handling of the real airplanes. So if that is the case, then they will have to take another path, which is actually strictly controlled by the Civil Aviation Authority Malaysia, where you have to start from the zero process, and it will take about 5 years. If you are the smart one, probably 5 years you may be able to get your license, but otherwise usually people take about 8 years to get their license. But it is a very interesting engineering job, which I felt that any people, especially for people like you all, can actually take. Yeah. I hope that that answer your question. Thank you.
Thank you, Ricky, for the answer. I think I do not have to elaborate further, but just to highlight to all of you, the one that being mentioned by Prof. Ricky just now is for the license to become an aircraft maintenance engineer, right? But the most important thing is that when you graduate later on in 1 year time, you have to register as a graduate engineer, right? So by registering with the Board of Engineers as a registered graduate engineer, then you are legally be allowed to work in any engineering field, right? Not just aerospace. You can venture into maybe other fields that are related. And as stated in the Registration of Engineers Act, normally the practicing engineer, right? When your background is aerospace, you should practice as an aerospace in the aerospace field. So you can go into aeronautical, you can go into astronautical, you can go to aircraft maintenance, you can go to aviation management. So there's air traffic control is slightly different. So you must practice within your knowledge that you already learn. It's not something that when you register as a graduate engineer, you register as aerospace engineer, but you are working as a electrical engineer field. It's not. It is against the act. It is when the time comes when we cover in term of the ethics and so on. Is you as the engineer must practice according to the knowledge that they already acquired. Okay, it's not that you just simply practicing something that are not within your field. So you are not a civil engineer. Suddenly you give advice to the to some people, to the society, about how to do civil engineers work. It's not. It is against the law, and it's against the ethical as a professional engineer. So so the first thing is get yourself registered as a graduate engineer, and then start collecting your work experience in the engineering field, right? So you require a minimum of 3 years before you are allowed to submit an application to become a professional engineer. So once you get the professional engineer status, you then be able to submit documentation to the authority. You can do certain things that a graduate engineer cannot do. You can supervise other engineers by becoming a professional engineer. And right after professional engineer, there is another level 2 professional engineer that we call it as the professional engineer with practicing certificate, okay, where you are then be able to open a consulting firm. All right. Okay, there are other questions from Nurul Ain. Engineers. So okay, I have a question about the engineers' social economic responsibility. Point of make provisions for design technology failure. May I know the details about it? How it works? Can you elaborate a little bit more? Right? Maybe yes, Ricky can answer that.
Okay. Which point number 4 is it? Do not hesitate to modify or redesign, or is it something? Okay. Make provision for consequences of design, process, or technology failure. Okay. Now let's say for example you design a wing structure, a horizontal wing structure. Yeah. Now the wing structure has been designed in accordance with the requirements of the authority. We know it has a load factor, yeah, built in of 1.5. I'm just giving this as an example. Now, no doubt you have do the wind tunnel testing. We have done the stress test. We have actually did the fatigue test. Yeah, we have done the shear test. No doubt we have actually done all these tests, and it actually passed. Yeah. But you also have to think about what if there is other element that is causing it to crack? What if there is a fluttering or vibration after some time? We are testing it as a normal cycle of structural stress. But what about those small vibration that because of the air load, it actually caused a crack? Do we have a backup? I think we can install a bracket. I think we can actually develop a bracket and put it in. And actually, this is exactly what happened to one of our airplanes. Okay. Now, the horizontal stabilizer of that wing, or the horizontal stabilizer of the airplane, has been designed perfectly well. No problem. Airplane has been flying and all those. But recently, this 1-2 years ago, we realized that one of the very small bracket that is actually holding one of the fairing, because of the very, very small vibration, it actually cracked. But that crack did not cause any catastrophe. That crack did not cause any flight characteristic changes of the airplane. And it was the inspection period that we came 2 years, every 2 years, when we open up, we actually saw two cracks, and that crack is long, 3 inches, 4 inches. It's long. But how come the system is still safe? Because of the additional bracket they put it in. So this is what it meant: make provision for consequences of design failure. That means they have missed that small little vibration part. But they thought, let's put in a bracket just to make sure that in case there is some other load that is actually coming into the structure, the bracket will take the load and crack. So the bracket crack, but not the main structure crack. This is what we meant, make provision for consequences of design failure. So this is another example. Yeah. So I don't know whether you can understand what I'm trying to say.
A very great explanation, Nikki. I hope Nurain can appreciate that about the item on make provision for consequences of design or process or technology failure. Okay, another question by Kishore about we must register within 1 year of graduation. The answer is yes. Basically, immediately once you get your degree certificate, you have all your transcript, you have to register yourself. I encourage everybody to register with Board of Engineers. It's only 50 ringgit for life. It's not yearly. It's just one time. One time you pay 50 ringgit and you already get registered. You do not have to renew every year. And the reason why you have to register just upon graduation is that you do not lose the experience, right? And of course, there are two things here. One is the losing experience. What do we mean by losing experience? That if you would like to, if you register the first day that you graduated from University Putra Malaysia later on, your experience will be counted, right? Let's say and register your experience will be counted towards your 3 years working experience as an engineer, and before you are going to be considered to be able to apply for professional status as a professional engineer to carry the IR status. If in the case that you do not register, right, you do not register, you wait until 5 years or 10 years, then you register, the 10 years experience that you already gone through for the past 10 years are not counted, because just simply because you do not register yourself. That is the first one. Okay. The second item is that if you do not register as a graduate engineer, immediately upon graduation, you are the first one. The first one is that you are not going to be employed. Okay, if you would like to apply for Malaysia airport, for example, they already imposed that any applicant must have a registration with the Board of Engineers. Without your registration as graduate engineer, your application will be just thrown away. They don't even consider. So Petronas already started with it. Galaxy Aerospace already started to take into account about the registration. So, and many more companies. I hope TS Ricky company also can also enforce this. Without the graduate registration with the board engineer, you are not going to be employed. In the case that you are being employed as a engineer, you are actually working illegally, right? Anyone that let's say you're working as an engineer in a factory, or in, for example, in Spirit Aero System in Subang, right? You are not registered. Yes, you are being employed, but at any time, the enforcement of the Registration of Engineers Act, let's say someone report or some issues happen at the factory, right? You yourself can be fined a maximum of 50,000 ringgit, as I already highlighted earlier, and the company themselves also going to be fined 50,000 ringgit. So it's only 50,000 ringgit only. It's not cheap. So that's why it's very important for you to register immediately upon graduation, so that you get the benefits of being a graduate engineer. You are going to be protected by the Registration of Engineers Act. It's not just for the public, it's also protecting the engineers, so against any illegal action, right? So I think that answer the question. So okay, yep, I open up other question. TS Ricky also very kind enough to provide exercise or assignment. Maybe Ricky, can you turn into the assignment page just now? Right. I think the second last page, right? There are 3 questions provided by Ts Ricky. So he asks you to choose only one, right? There are 3 questions there. I believe I will create an account in the Putra Blast so that you can submit your answers. Right? So as I said, this is the activity, right? We have a 3-hour session. 2 hours is the lecture and 1 hour is the activity. And this particular 1 hour activity is 1 hour credit is actually 3 hours activity. So looking at the question just now, you can spend maybe half an hour or 1 hour to just write with 1 or 2 pages of answer, right? And is it okay, Ricky? 1 or 2 pages of answer would be sufficient enough?
Yes, that is sufficient. Thank you, Prof.
Okay. I suggest that you submit the answers in Putra Blast. Later on, I will create the platform where you can submit your answer. Do not have to spend a lot of time. Just what you think about being your opinion. Okay, for example, like question 2, describe what is your role in engineering field in responding to society needs as well as shaping them realistically. So do not just find it in Google. So I would like you to I would like you to try to express what is your own thought on the question that being given here, right? Maybe someone can answer it differently. Maybe other person, they can answer it differently. So we would like to see what is your thought based on the lecture given by Ts Ricky. Probably is best. We will open it until submission by next week. Okay, of course, you won't spend a lot of time, just half an hour or 1 hour to cook something on the answer, and this is also going to contribute part of the coursework assessment. Right. Anything to add on this, Ricky? Is it okay about the submission and everything?
Yeah, that's fine, Prof. Thank you.
Okay. And one more thing, I will also edit this particular session and put it in a proper video, and then you can refer to it later on, and if at your own sweet time, maybe before you sleep again tonight, you can hear the video again to help you to answer the question given by Prof. Ricky. Right. Any other question before we end our session? It's already 2.5 hours session. Okay, everything good?
Prof,
Yes,
I have a question.
Yes, Glenn.
Good morning to everyone. But this is for Ts Ricky. I would like. I'm just interested about the aircraft engineering work. Can you share about your experience about your routine inspection for the aircrafts in Malaysia? Thank you.
Okay. As an aircraft engineer, just like any other engineers, the primary paradigm, the primary paradigm in our mindset is always about safety. Now, in order for you, for us to exercise as an aircraft engineers, the basic foundation of our knowledge is very, very crucial. For example, we must have a very strong understanding of the aircraft construction, aircraft systems, and if we talk about aircraft system, it's actually quite a huge and a complex systems, and also not only you have a very strong foundation and strong system, you actually have to be able to actually apply your skills, your thinking skills, and also your hand skills hand skills. Actually, the aircraft engineers are practical engineers. Practical engineers means that we are most of the time we are out on the floor solving problems that is on the airplane. Normal routine problems, for example, servicing lah, component removal lah, panel installation lah, this check and all, this check and next that check lah. This we have the technician that actually they're doing for us. But when the aircraft has faults, for example, aircraft pressurization system fault, aircraft cannot pressurize. No matter how they try to do it in the aircraft, in flight, they cannot pressurize the system. You know, this fault becomes a fault that the engineers will go in. Engineers will dive into the system, collect all the data from the parameters of the airplanes, do a study and analyze the data, and then we base on our knowledge and understanding of the operation of the whole aircraft system, we must come out with a solution or some potential solution. Solution number 1 is like this, solution number 2 is like this, solution number 3 is like this. So you can see as an aircraft engineers, we are not just about, it is not just about inspection. It is about how much knowledge you have in the system for you to be able to dive into the system, carry out all the analysis and the research before you come up with a conclusion and rectify the aircraft. Of course, the rectification usually will just pass it to the technician to replace the thing, you know. And then after that, we're going to do the system functional test again. So there are times there, as an engineer, we have the authority to call for test flight. And I used to call for test flight, you know. But before I call for the test flight where the chief pilot will come in, is that I need to be able to explain to them the complete process that has happened and why are we going for this test flight. So you're talking about life here, you know. If your diagnosis of the system is not good, you wouldn't know. Aircraft takeoff might crash. Aircraft takeoff cannot pressurize. You might even end up in an incident. So engineers' role, core function is like that. That is how we work. Of course, we have the routine inspection. You know, every 12 months we have to do this inspection. You know, the servicing. You know, this routine kind of boroscope inspection and all those. To me, that is still not so difficult. The most difficult part is the knowledge, the skills, and also the understanding of the principle of the whole aircraft system. That is complex. That is complicated. Yeah. Working as an aircraft engineer, I felt that it is very enjoyable. I enjoy my 32 years. There are times that I have to make very important decisions. These decisions made is not about 100,000, 200,000 kind of budget. We are talking about multi-million budgets. The engineer, if you say yes, this aircraft is acceptable and can be purchased, it comes from an engineer. Yeah, I've already made quite a few of these decisions. Multi-million dollars, fly to US, check the airplane. There are 4 or 5 airplanes there. Go to the airplane one by one. Everybody will claim that the airplane is the best. But if you are an engineer, you know which one is the best one, man. By looking at the aircraft structure, by looking at the system, by looking at the dirt on the hydraulic lines, you will know whether this aircraft is very old or this aircraft is still relatively quite new. These are all things that engineers can have this kind of capability. But it requires a lot of training, a lot of discipline, a lot of focus, and you must have a passion in the field that you're in. For example, I have a very strong passion in aircraft engineering and maintenance, and therefore I take it very far. You know, I take it very, very far. So there is still a good industry for opening for any other people that is interested. I hope I answer your questions. Thanks.
Thank you, Tis, Ricky. Thank you, Prof.
Okay, so thank you very much, Ricky. And I believe if you have any other question, you can contact Ricky, probably through me, or Ricky, you would like to share your email, or you I can share your email with them, right? Yes, okay, very good. So, so anybody would like to learn more about aircraft maintenance, especially the in Malaysia as well as in the world. Aerospace engineering is not just Malaysia or local industry; it is a global industry, right? So, with that, thank you very much, Ricky, for your valuable time, and hope that we can also have other sessions with regards to other topics. And as I said, from time to time, we will have a special lecture by invited experienced engineers, whether it is in aircraft maintenance or in manufacturing or in engineering design and so on. So I believe there will be other session with Prof. Ts. Ricky. Again, thank you very much for your valuable time, and for the rest of the student, make sure you submit the exercise given by Prof. Ts. Ricky just now, and I'll see you guys again next week on Monday to explain more on the activities with the society. So with that, stay safe. We are still not yet free from the COVID-19 pandemic. If you are in your college or in your very nearby UPM, you are allowed to enter the university, but make sure that you follow the SOP, standard operating procedure. So we do not want to spread any more disease or COVID within UPM. And we also do not want to spend 10,000 ringgit to pay unnecessarily, right? Okay, with that, thank you, Ricky, thank you, everybody. Assalamualaikum warahmatullahi wabarakatuh. Bye bye for now.
Thank you.
Thank you, Prof.